Welcome along, explorer. If you're wondering what's out there in the universe, well, you've come to the right place. Because every week, we search through space to find some real secrets. It's a brand new Fun Kids Science Weekly. My name is Dan. Thank you so much for being there, for listening, for following. Remember, you get bonus episodes as well if you're subscribed to Fun Kids Podcasts Plus. Now, this week, we will learn about some of the smallest things in the universe.
Molecules bring kind of atoms together so that they can share electrons, and those electrons can sit together in a pair. And that's why atoms don't tend to float around on their own. They want to share their electrons with another atom, and that essentially is what creates a molecule.
And our search to discover the greatest science ever takes us back in time, heading hundreds of millions of years ago.
There's always going to be something more to discover. There will always be a new discovery right around the corner. You won't necessarily even see it coming. That's why it's a discovery. You don't expect it. You get ready for the excitement of what's going to come next.
And you can hear about a big bug. It's all on the way in a brand new Fun Kids Science Weekly. Let's kick things off with your science in the news. The US space agency NASA says that its Voyager 1 probe is once again sending good information back to Earth after months of spouting gibberish. Now, Voyager 1 is 46 years old. It's humanity's most distant object. It's just been floating across the universe, and a computer fault stopped it sending readable data back to us in November. The engineers have now fixed this. Now, Voyager 1 is more than 15 billion miles away. It's so distant, it takes any message almost 1 day to reach us. And it's travelling to parts of the universe that we have never been, so the fact that it's still looking and sending back data that we can read and analyse, that's brilliant news. Also, in less good news, Antarctic wildlife getting exposed to the sun's damaging rays has increased in recent years. Scientists say that it means animals down there near the South Pole are getting sunburnt, and even worse, it's because of a hole in the ozone layer. You might have heard about that. It's a protective barrier of gas in the upper atmosphere, but there's a hole that lingers right over Antarctica for so much of the year, and it lets through really damaging parts of sun rays. And a major cause of ozone loss is thought to be the amount of smoke from Australian wildfires that we've had recently. And experts think that's been fueled by climate change. So again, the decisions that we are making are affecting things that we care about all over the world. At this point, it's making a lot of South Pole sea life and creatures getting sunburnt. Also, their eyesight is being damaged by those UV rays from the sun. And our final story this week, a hedgehog has had to be deflated after swelling up to the size of a football. It's a female hedgehog. It was inflated to twice its normal size, discovered near Quedgeley in Gloucestershire, and she was so large that she was spotted by a passenger on a bus nearby. Let's find out more with Emily Harper from Wild Hogs Hedgehog Rescue. Emily, thank you so much for coming on. Just so we can start well, how is the hedgehog doing?
She's recovering well in the rescue. She's finished her initial treatment and we're just assessing her now, but she seems to be doing much better. Thank you.
No, please, that's what we want to hear. So how were you first alerted to this hedgehog perhaps having a problem?
So we had a call from a neighbouring rescue saying that a man on the bus had seen a hedgehog from the bus but couldn't pinpoint her location. So we knew there was something going on, and then she was found by a dog walker and brought in to us. So
then as a rescue team, what do you do? Because I don't know much about rescuing wild hedgehogs. But I can't imagine there's many emergency situations, right? That might be completely wrong. But what do you do when you find this out?
So with balloon syndrome, we needed to deflate her straight away because it was affecting her breathing and it was affecting her movement. The swelling had become so bad that she was really struggling with breathing. I'm trained in rehabilitation. I've been doing it for the last 6 to 7 years. So I deflated her, and we use a wide gauge needle to do that. So So just one that will let the air out, and gently squeezed her and some of the air came out, and that made her much more comfortable. And then we sent her to our vet, and she had an x-ray to make sure that there was nothing broken inside, no chest problems, no broken ribs, no lung problems. And they deflated her completely while she was at the vet's.
When you're deflating a hedgehog, what do you have to be worried about? What are the risks that could happen with trying to squeeze a little bit of air out of quite a small hole?
Yeah, you obviously need to do it gently. You don't want to create a big wound, and you need to make sure everything's sterile so you're not creating any further infection. The balloon syndrome is generally caused by a bacterial infection under the skin. So in essence, the hedgehog may get a little wound when it's walking about, or something may have happened to it. Infection gets in under the skin, and hedgehogs are a bit different from many other animals. So they have their layer of skin, and then they have their muscles and skeletons inside. And in between the two is a gap of air normally. And if an infection gets in there, then it bubbles away. And if the outside seals, it gets trapped, which is why the hedgehog ends up ballooning up. So we have to really gently release some of that air to let the hedgehog come back to its normal size, because the skin gets stretched really tight as well.
So with balloon syndrome, you say air is let into this little pocket just under the top layer of skin. Why would that grow? Why is it bubbling away?
If an infection gets in, so a bacterial infection from a cut or wound gets in, then that creates the gas, which inflates the hedgehog.
So this is a story really unusual. I've never heard anything like it. How common is balloon syndrome in hedgehogs?
So we take in 400 to 500 hedgehogs a year, and we see probably one a year. So it's not completely out of the question. I've certainly seen more before, but we don't see them every day.
It must be quite tricky, but handling hedgehogs very simply and making the hole to let the air out. What do you do to protect yourself with all the prickles?
We wear gloves. We always wear gloves when we're dealing with the hedgehogs. Actually, the hedgehog feels very light when it's got balloon syndrome because of all the air, and she wasn't able to move very fast. So she was very compliant. I think she was happy for us to help her, really, because she just couldn't move.
Well, because they're so spiky and we don't see many of them near where we live, and they seem to be quite shy creatures, and we don't come in contact with them too much. What are they like? Are they angry? Are they aggressive? Are they quite timid? What's going on?
Usually they're fairly timid creatures. Their first reaction is to freeze or to curl up in a ball. So generally they tend to go defensive. You very rarely see them being aggressive. The only time we tend to see that is in mums protecting their babies when they've been through quite a lot in the rescue. If they've been disturbed in a nest and brought into us, sometimes they can protect their babies. But generally, they're really gentle creatures. They're really lovely, really obviously nocturnal. So we don't get to see them in our daily lives, but they scurry around most places, most towns and cities at night, looking for food and living happily in our gardens.
Amazing. It's been brilliant to chat. Emily Harper from the fantastic Wild Hogs Hedgehog Rescue. Thank you so much for joining us.
Thank you.
All right, then, let's answer some of your questions. If you ever have anything sciencey that you want answered about anything at all, make sure you leave it as a voice note for me on the free Fun Kids app. That way, I can do the digging myself. If I can't find anything solid for you, I'll ask a proper expert in the field, a genius who has devoted so much of their life reading books, looking through the internet, and they can answer it. So we've got all bases covered. First question this week was sent as a message to me on the Fun Kids website from Kitty in Twickenham, who also wants to say hello to her pets Roo and Benji. Kitty wants to know, how do touchscreens work? It's a brilliant question, Kitty, because we use touchscreens so often, right? On our phones or our tablets, probably in the thing that you're listening to this on right now, that might have a touchscreen of some sort. We take it for granted that they just work, right? They're there. Oh, they work. Of course they do. But how? Well, most touchscreens use something called capacitive touch technology. It uses the basic bit of science that says everything stores an electric charge, even your hands. Everything has a small amount of electrons running through it that can create a charge. Now, the touchscreen has a few layers. The top layer has a very thin electric charge that always runs through it. So when you touch it, it disrupts that charge because suddenly there is an added bit of electricity, your own, from your thumb, and that disrupts it. It disrupts the normal electric charge that's running through the screen. So it can pinpoint exactly where your finger is because something different is happening there. And then underneath it, there's a layer of screen which shows you the cursor or the mouse wherever your finger is, so it can point you and show you what's happening. A good way to think of it is like a pool of still water. When you put your finger in it, it ripples outwards from there, doesn't it? Because all the other particles in the pool are being affected by you touching it. It's the same with the electrons in the electric charge on your touchscreen. Think of it like that, Kitty. Thank you so much for the question. Let's get another one on then, sent in by a voice note to the Free Fun Kids app. This is from Harry. What do you have, Harry?
What are molecules made from?
Harry, thank you very much for that. So what are molecules made of? Well, molecules are pretty tiny anyway, aren't they? Let's find out with Dr Catherine Walsh from the University of Leeds. I guess let's start with what a molecule is, because they're pretty tiny.
So molecules are kind of the fundamental building blocks of really everything in the world around us, right? So our atmosphere is made out of molecules. Molecules are in the air that we breathe. And also humans are made out of molecules as well, right? So all the structures that allow us to live, like our bones, like our skin, our hair, they're all made out of molecules as well. So they really are the fundamental kind of building blocks of material, including living material.
So they are the building blocks. Harry wants to know what builds the building blocks. So what are molecules made of, Catherine?
So you can break molecules down, even though they are really tiny. And the building blocks, or if you like, the Lego pieces, because you can kind of think of molecules a little bit like Lego as well. So the bits that make up molecules are called atoms, right? And you may have been in a science lab, or maybe your teacher at school has a map on the wall of all of the different atoms or elements that are possible to exist in the world. And those atoms are actually the very basic building blocks of molecules. So just to take one of the examples that I gave at the start, so our atmosphere, which is the air that you breathe, so that's made out of molecular oxygen and molecular nitrogen. So this is oxygen, which is an atom, but it's two oxygens joined together to form a molecule, and that's about 20 or 1/5 of the atmosphere, 20% of the atmosphere. And much of the rest of the air that we breathe is nitrogen, which is also in molecular form. So two nitrogens kind of joined together, if you like, in a bond to make that molecule. And another really important molecule for us and also for life on Earth is water, right? So water's everywhere. I have a glass of it here because I like to stay nice and hydrated every day. And water is a very simple molecule as well. So water is one oxygen atom, which is joined together with two hydrogen atoms. So you may see water also called H2O, which is its chemical formula.
So, at a very basic level, an atom is one thing. If you put two atoms together, you get a molecule.
You do. If you had very, very, very good microscopic vision, you tried to look down and see the structure of an atom, then what you would be able to see is this really, really tiny center bit of the atom, which is called the nucleus, and it's really, really dense, really tiny, and it's surrounded by kind of a sea or a shell of fundamental particles called electrons. Now, what's very interesting about electrons is that they don't really like to be on their own. And some atoms have kind of lonely electrons. So these electrons that are on their own and they don't have a friend to sit and eat lunch with. Well, actually, molecules bring kind of atoms together so that they can share electrons, and those electrons can sit together in a pair. And that's why atoms don't tend to float around on their own. They want to share their electrons with another atom. And that essentially is what creates a molecule.
With atoms, do we know why they are here? Do we, without getting into the big question of why we are here from the universe, but do we know how, for instance, an oxygen atom is made, why that exists, why the smallest building block of the universe is there?
So now you're getting on to what I actually do in my day-to-day job, which is I'm an astrophysicist, right? So I look at atoms and molecules in space. And what's really interesting is that at the beginning of the universe, so way, 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 way back, so it's a long, long, long time ago, there was only hydrogen and helium. So those are the two lightest atoms that we know of, and they were formed in what is now called the Big Bang. So your question was, how did we make oxygen? Well, that's really interesting, because what happened in the early universe is that some of the material came together, cooled down, and gravitationally collapsed and formed the first stars. Now, in order for you to make heavy atoms from lighter atoms, you need really, really super high temperatures and really, really high pressures. Like, you really have to squish things really, really tight together, very high temperatures. And that's what you can do in stars, right? So what stars do is that they bring hydrogen and helium together, just like our sun, really high temperature, really high pressure, and it smushes those atoms together and it forms heavier atoms like oxygen, but also atoms like carbon, like nitrogen, carbon that we're made out of, and nitrogen in the air that we breathe. And how those atoms then ended up here on Earth is because stars will eventually run out of fuel, and they will do a big catastrophic boom, and they will throw all those new, fresh, heavy elements out into the universe to then end up on our planet and help us to create the atmosphere that we breathe and the water that we need for life.
There we go. Harry, a big answer to your question about tiny, tiny things. That is what molecules are made of, and that's how they got there too. Dr. Catherine Walsh, thank you so much for joining us.
No problem at all.
Thank you so much to Catherine Walsh from the University of Leeds, finding out what molecules are made of, hearing about some of the smallest things in the universe. If you have a question that you want answered next week on the show by a proper genius, make sure you leave it as a voice note for me on the free Fun Kids app or at funkidslive.com. And now, let's look at some of the most strange, weird, unique and deadly things in the universe. It's time for Dangerous Dan, and we're headed into the streams, the rivers and the seas all around Asia to take a look at the giant water bug. You do find them across the world, but mainly they're in Asia, and they're called all sorts of things across the globe, right? Depending on where they might be, they could be called electric light bugs, alligator fleas, alligator ticks, or even toe biters. That name, toe biters, shows exactly what these little beasts can do. Now, they're some of the largest insects in the world. They can grow to over 12 centimetres long, which is pretty big. It's huge for an insect. They've got quite a flat body, normally brown or green with thick legs. They're known for their big bites. If they're provoked or if they're handled carelessly, their bite is a brute. It makes you swirl, it causes agony. It's mainly dangerous to animals, though. They're aggressive predators that stalk fish, snails, crustaceans, even amphibians. The largest can even capture and feed on turtles or snakes. Now, normally they lie motionless, dead still at the bottom of the water, and they wait. They wait, and then they pounce. They strike, they bite, they use their huge body, that massive brute force, to take down their prey, which is why they're called toe biters in some places, and it's why the giant water bug goes straight onto our Dangerous Dan list. It's the Fun Kids Science Weekly, and we are back with a battle of the sciences on our quest to discover, once and for all, which is the best science. If you've never heard this before, every week I invite on an expert and they prove why their field should come first. Today, it's a bit of time travelling. We're talking about paleontology with Jimmy Waldron, who joins us. Jimmy, we start off in the same way. You have 1 minute to pitch why paleontology is the greatest science of all. Your time starts in 3, 2, 1, go!
Hello, kids. Welcome to a world before human beings. A world where the amazing creatures that once roamed this earth are yours to discover and understand. Welcome to a world that includes such fantastic creatures as the Tyrannosaurus Rex, the mighty Triceratops, and the incredible brand new Ichthyotitan. Welcome to a world where you can not only find out where life has come from, but also use those skills in your minds to see where life is going afterwards. Do you want to talk about ancient plants? We've got ancient plants. You want to talk about ancient animals? We've got ancient animals. Do you like fish? We've got the biggest fish that ever lived in the world. And everything you learn in paleontology, you can apply to other things you're interested in. You want to learn about zoos and zoology? Great. Paleontology takes you there first. Learn about physics by seeing how bones fit together. Learn about math by seeing how fast a dinosaur can run. That's a thing you can figure out. And learn all the different sciences that are underneath paleontology.
There we go. And there's your minute, Jimmy. We got there. Well done. That was brilliant. So many questions. Now, so we know a little bit about dinosaurs and the wide range of time that they were around. We've got an idea of why they're not here now. How much more is there left to discover? How much of the knowledge of everything about dinosaurs do we think we have a handle on?
The answer to the first question is there's always going to be something more to discover. There will always be a new discovery right around the corner. You won't necessarily even see it coming. That's why it's a discovery. You don't expect it. You get ready for the excitement of what's going to come next. And so right now, we know of more than 1,400 individual species of dinosaurs, 1,400 different kinds of animals. But we know that in the animal kingdom today, we have so many more than that walking around. Think of every beetle, every bug, every cat, every animal that you can think of that is out there in the world today. They're all doing important jobs in the world. They have ecological roles. And those same roles existed when the dinosaurs were around. So even though we know about a lot of the big ones like the Stegosaurus and the Dreadnoughtus and all these amazing creatures, we know a very little bit about the actual natural world that they lived in. And so that's why it takes new paleontologists, and the next generation of paleontologists who are listening to this right now are the ones who are going to help us to fill in those bits of information that we haven't found yet.
And in your time discovering that information, what's been the one thing that you're just amazed to have learned, something that has blown your mind about dinosaurs?
So, years and years ago, when we first found big dinosaur bones in the ground, there was such a level of excitement behind them that people were like, we need to get as many bones out of the ground as we can. So they started doing everything. They would use big excavators and massive trucks and even dynamite to blow up mountain walls to try and get the dinosaur bones out. And sure enough, they got the bones. But now we are much more patient. When we find a really cool dinosaur bone, like this Triceratops tailbone that I've got here, we take a look not just at the bone, but at the whole area around it. Because we can find a lot of information from fossilized plants, fossilized insects, trace fossils like footprints, and even, believe it or not, chunks of fossilized dinosaur poop. That can tell us what an animal was eating, how it lived, what the environment was like at the time. And so we've moved now from wanting to find the biggest and the baddest looking dinosaur bones to really learning more about the world in which they lived. And to answer your question directly, I think one of the coolest things that I've learned about dinosaurs in the last few years is that we can tell how old they are by looking at lines of growth in their bones, the same way you would count the rings of a tree to see how old the tree is.
So my last question, Jimmy, we've spoken about what you've learned and your career so far. If I were to throw you forward 40, 50 years when you think it's time to call it a day, what's the one thing that you really want to know? What's that question that you want to get the answer to in the future?
I would like to know more about the behaviors of these animals. I'd like to know more about how they actually interacted in the world and how smart they really were. We can figure out so much from the bones and from the materials that we find, but behavior and the way that animals interact with each other is not often found. Actually, Dr. Lomax has a great book on this. He did a book where he studied 50 different instances of behavior trapped in fossils, and the book is called Locked in Time, and it's given us a picture of how these creatures actually interacted with each other. I would love to know more about those things that don't fossilize. And how do we figure that out? That's going to be a fun question.
Well, there you go. Proving why paleontology should get first prize and be the best science of all. Jimmy Waldron, thank you so much for joining us.
Absolute pleasure, Dan. Thank you so much. Bye, everybody.
What do you think then? It's good fun to learn about dinosaurs and to travel back through time, right? We've had a few Battle of the Sciences over the last few weeks. What do you think is the best science so far? Let me know. You can send a message to my page over at funkidslive.com. Now, earlier on, we heard all about molecules, didn't we? Super, super small things across the universe and what's even smaller than those with Dr. Catherine Walsh. And it fascinated me, so I wanted to find out more about what they are and what they do. So we're calling on our good friend K Mystery. She is the superhero alter ego of Karina. They explore the world of chemistry together. And this week, we're hearing all about heat transfer. And we're getting shrunk down to take a look inside her fridge at a molecular level.
Karina's Chemistry, with support from the Royal Society of Chemistry.
15, 16, Colonel Whiskers is 17, and Major Meow makes 18. You see, what it is, there's this cool new collectible card game called Crazy Cats, but my mate Misha has only just started collecting the cards. It's so frustrating waiting for her to buy some more. I wonder if K-Mystery has any cards.
So, let me get this straight. Here I am, a chemistry superhero alter ego, and you want me to play Crazy Cats?
Oh, well, I guess I really want you to solve my problem. You said chemistry is good at solving problems. Can you magic up more cat cards for Misha?
No way, that's cheating! But don't panic, because there is something you can learn from chemistry that will help. You've got a fridge in the kitchen, right?
Yes. Pretty sure there aren't any cards in there, though.
Excellent. Come on then, we're going in. Oh, I knew I should have worn my new neon earmuffs. So, any idea what fridges do?
They keep stuff cold by, I don't know, shoving a load of cold air into the food?
They do keep stuff cold, but they're not putting cold in, they take heat out. The cold is what is left behind. Oh, let's check out that jar of pickle. That jar of pickle didn't look like it was moving much, did it? Bit different now that we're down with the molecules.
It's mad in here. I can see that the molecules are all jiggling about.
And that's because of the heat energy they contain. That heat energy wants to find equilibrium.
What's equilibrium?
It's kind of a state where everything's equal. Heat energy wants to transfer itself to less hot materials until everything has the same amount.
Yeah, and it looks like it knows there's more cold out there than in here. I can see the heat energy is moving, like in waves, towards the edge of the jar.
And into the fridge. The cold pipes in the back of the fridge absorb this heat energy. And as they're super cold, they can take a lot of heat energy from food. They keep on taking heat energy, slurping it away until the food is super cold.
So how do the pipes stay cold? Don't they end up being warm from all the heat they're soaking up?
No, because the pipes are constantly refilling with liquid. And it's super cold. The liquid is way colder than water would be. It's often something like isobutene, which stays sloshy even when it's below freezing. Uh-oh, I think someone's opening the door.
Dad's looking for a snack. Cheeky. He's meant to be on a diet. Wow. It suddenly got really warm again. All the cold air got out. Oops, all the hot air got in.
You're getting way good at this. Yeah, that's why fridges are well insulated. That means that they are good at preventing heat from outside coming in.
I think our house is insulated.
Yep, insulating is handy in lots of ways. Like your house, and when you wear a big coat on a cold day. That's insulation too.
To trap my heat inside so it doesn't go trying to share itself about with all the cold stuff outside.
Yep. Heat energy transfer is all about sharing. Insulation is all about, well, not sharing. Now think about your collectible Crazy Cat card conundrum. Misha has 2 cards, you have 18. You can only play when you have the same amount, like an equilibrium of cat cards. So...
Oh, right. I should share my cards. If I give her 8, we'll both have an equal amount of 10.
I can't believe you didn't work that one out for yourself. I thought mates shared things all the time.
You're right. I'm a rubbish mate. Maybe I'll be a better chemist one day.
Karina!
Well, I gotta go. Bye for now, K-Mystery.
See you soon.
Karina's Chemistry, with support from the Royal Society of Chemistry. Find out more at funkidslive.com.
And that's it for this week's Fun Kids Science Weekly. Thank you so much for listening. If you have any science question that you want answered on the podcast next week, make sure you leave it as a voice note for me on the free Fun Kids app or at funkidslive.com. Either I'll do the digging or I will find a genius who knows all who can tell you. You heard from Kay, Mystery and Karina today. We've got loads more brilliant podcast series. Google, Apple, Spotify, wherever you get your shows. You can find it at funkidslive.com too. And Fun Kids are our children's radio station from the UK. Listen all over the country on the app, on our website, or if you've got a smart speaker, wake it up and ask it to play Fun Kids.